to choose from. It's like a darts game. So, the idea of today's discussions started a year ago when the project BBioNets began. And at some point, we had the idea of bringing a lot of people together in a virtual room to exchange ideas. So this is why you are all here today. Let me start from offering some very basic information about our project before we proceed, and just, structure the day. So first, some house rules, as we say. It would be very much appreciated if you keep your microphones closed and your camera switched off until it's time to talk to each other and ask questions during the discussion panel. The event, as Daphne mentioned earlier, will be recorded. So if you don't want to be visualize there, just switch off your cameras. And you can use the chat button at the bottom right to ask any questions. Or at some point, when time comes, you can just switch on your mic and tell us about it. The agenda of the day, the structure of the meeting. At the beginning, a very, very short overview of the project and our work in Poland and Czech Republic, the results of our analysis. And the main course of the meeting will be the panel discussion, where we invited 6 experts to talk about their research work and their findings and case studies from the 2 regions. At the end, we prepared a couple of questions for the experts, but also the audience will be free to ask any clarifications they need. So briefly about BBioNets. As I said, it's an Horizon Europe project, started last November, so it's 1 year old. Our aim is to support primary producers to be more involved in the supply chains, learn about bio-based technologies and solutions. This is the main aim of the project, the core of our project. And at the end of the day, contribute to boosting the agricultural and silvicultural economic growth in an environmental sustainable way. How we plan to do that? First of all, we set up what we call forest and agricultural networks, which is nothing more than a network comprised of primary producers, advisors, experts, multipliers, regional authorities in each region, in order to act as the seed of our next phase of the project. So we need to bring people together and start a multiplying effect of knowledge sharing and networking and advisoring. Then we started our own back office work by matching bio-based technologies to regional dynamics and potential to see what is more relevant to each region. The next step, as I said, we are in the first year, so the second 2 years of the project will be about raising awareness and networking and supporting actually active actors, primary producers in the partner countries. And at the end of the day, of course, we will make sure that all the experience and the knowledge created will remain for the after the project phase. I said many times our regions, and this is our regions, 6 countries: Ireland, Spain, Italy, Greece, Czech Republic, and Poland, where we have a nice, we believe, consortium, comprised of different expertise. And going beyond our countries, we grouped the regions together with a kind of regions that have similar characteristics in terms of climate, in terms of agriculture sectors, and so on. So these are the pairs, what we call them, the ETRs. And today is about Central Europe, Czech Republic, and Poland. Last week, we had a similar workshop for the Atlantic area, Ireland and Spain. And next week, for those that are interested, it will be Italy and Greece. It's like a football match, one against the other, but it's not actually. So the core of our project is primary producers, especially in the form of operational groups. As you know, there are many years that this concept is implemented across Europe, and we need to enhance that concept to push forward the work that is being done within those operational groups and promote the setup. We chose the bio-based technologies as our sector of choice, of focus, which means technologies or practices that use non-food feedstock, circularity principles, or both to deliver diverse products. This is a definition used in the academic work, but also is embraced by the Commission. So, this is my part about the project. If you have any questions, please just ask. Otherwise, we would like to proceed with the analysis of our work, the results of our work in the two countries. So, Mark Gorzata, or because I don't see any hands raised. Someone has raised his hands or not?
I think there is a hand raised.
Yeah, sorry, Nikos.
Good morning again, Jakobos. This is great. The project is very aligned with the current mandates according all the EU Green Deals and SDGs. Regarding the OGs, have you incorporated the OGs in this project, or you are producing something for the OGs, existing or the future ones?
Directly as partners, we don't have OGs. We have those entities who support OGs, even though in certain cases the partners are involved in OGs. So we don't have them, we have them indirectly through our partners who play a double role. They are involved themselves in OGs and they support. Okay, Mark Gorzata, the floor is yours for the Polish case.
Okay, so let me share my screen. Hope I will choose the right one. So please let me know if you can see the right presentation.
Yes, we see.
Yes. Yes, okay. So I will just briefly talk about the agricultural waste management. Sorry?
Full screen.
It is in full screen. Okay, so I'm not sharing the right one, I guess. Yes?
No, just presentation mode.
It is in presentation mode, but I probably shared the wrong screen. So just a second. Maybe it should be the screen and not the presentation. How about now? Perfect. Okay, so, thank you. So I will briefly talk about agricultural waste management in Poland. Just a quick introduction. My name is Małgorzata, and I represent the Institute of Soil Science and Plant Cultivation, which is the largest research and development center in Poland, supervised by the Ministry of Agriculture and Rural Development. You can see on the map where we are located. It's Puławy, a town in southeast of Poland. And we carry out a range of activities which comprise soil science, microbiology and biochemistry, crop production analysis, economic effectiveness of field production, environmental modeling, climate change mitigation, spatial analysis, biomass potential, and renewable energy production possibilities. Just to introduce the topic of agricultural production in Poland and in EU, agricultural sector is very important in the Polish economy. Poland has 1,300,000 of agricultural farms, most of which are family farms, so not very big farms. The average size is around 11 hectares. But Poland contributes to the gross value added of the agricultural industry in the European Union with 6.2%. Agricultural production in Poland is dominated by cereal production, but when it comes to livestock production, bovine and pig livestock dominate. Agricultural production in Poland is dominated by crop production, as I said, which you can see in this graph, that most of it is cereal crop production, which is cultivated on almost 50% of agricultural land in Poland. When it comes to livestock production, we have mixed farms and livestock production farms. Mixed farms dominate with a share of 43%, and the most animal husbandry is focused mostly on breeding cattle, swine, and poultry. And now to agricultural waste, which is our topic of discussion today. So when we think about agricultural waste, we mostly think about crop residues, animal manure, feces, urine, bedding materials, and stalk, leaves, straw remaining after harvesting of cereal. But agricultural waste comprises many more categories, such as agrochemical containers, after using pesticides, herbicides, fertilizers, or leftover feed from livestock production. But also harvest and processing waste, so fruit peels, vegetable trimming, damaged or rejected produce, or some byproducts from food processing, packaging materials as well, and green waste from trimmings, prunings, grass clippings. So what do we do with this agricultural waste? It is, of course, very important to manage it sustainably, so to prevent soil and water pollution, greenhouse gas emissions, and health risks for the environment, for humans and animals. So one way of sustainable waste management is reusing, recycling of residual or waste biomass. And it can be in form of using, for example, animal manure as organic fertilizer, or for example, for energy production. At Jung, at the Institute of Soil Science and Plant Cultivation here, we conduct agricultural biomass monitoring, which comprises 3 categories: plant production, animal production, and agricultural and food industry, which is processing of products from the 2 above categories. And data used for this monitoring comes from a database on products and packaging and waste management, but also from the Agency for Restructuring and Modernization of Agriculture and Statistics of Poland. Based on this data, we can show you, for example, what agricultural biomass resources available in Poland look like. So those biomass residues coming from crop production comprise mainly straw. Here you can see the distribution of agricultural residue biomass divided into voivodeships in Poland. And as you can see, this residue is most abundant in Lubelskie Voivodeship, Wielkopolskie, Dolnośląskie. For those of you who do not know very well the administrative division of Poland, you can see that on the map. Here we have biomass residues such as grass or straw. And as you can see, the most abundant, those resources are the most abundant in the eastern regions of Poland. When it comes to livestock biomass available in Poland, it's, well, biomass production comprises mostly cattle and pig production. So as you can see in the graph, cattle accounts for almost 90% of total livestock biomass available. And again, we can see it's divided into voivodeships. The biggest amounts of this kind of biomass resources we can find in Mazowieckie and Wielkopolskie voivodeships. And the third category I've mentioned is the agro-industrial residues in Poland. Those comprise waste generated from agriculture, horticulture, hydroponics, fishing, forestry, hunting, and food processing. And they also constitute quite a large amount of biomass residues. As you can see in the forefront of the generating of this type of biomass residues, Wielkopolskie Voivodeship can be found, with quite a lot of food industry side streams. So what can we do with this amount of waste biomass, residual biomass? When we calculate the theoretical potential, for example, of manure, so livestock residual biomass, livestock waste biomass, theoretical manure potential in Poland amounts to as many as 82 million of tons in total. However, we cannot use all of it for the purposes that I've mentioned, for example, for the energy production. So for this purpose, we need to calculate the surplus of manure. Here you can see it divided into two maps. The one on the left shows manure surplus from mixed farms, so both livestock and crop production. And clearly we have a lower amount of biomass from mixed farms because some of it is used, for example, as an organic fertilizer, which is a very good thing. For example, because we can reduce the amount of other fertilizers used on agricultural farms, so we can promote nutrient recycling practices. About this topic more will very soon talk about our colleague, Piotr Skowron. And on the right, we have manure surplus from landless farms, so only those with livestock production. Here we can see a clearly larger amount of manure. And based on this calculation, we can see where, for example, a biogas plant could be located in Poland, where we would have the largest resources for the biogas production. This type of information is not only prepared for the area of Poland. We at Jung offer also this type of data for the area of Europe. And here I will briefly show you a geoportal available on a website of another project we carry out at Jung. On this map, you can see the theoretical potential, for example, of biodegradable municipal waste or theoretical potential of food waste for the European countries. If you'd like to see more and check any other resources, you can visit our toolkits at the address BioRural Toolkit EU. So I invite you to do that.
Malgorzata,
And
can you speed up, please?
yes, and I'm wrapping up. This is the last slide where you can see the theoretical potential of manure in the area of European Union. So that's it from me. I hope I introduced a bit the topic of agricultural waste management in Poland. And if you have any questions, I guess no time now, so we can.
Thank you very much. It was
leave it
a good overview of what is going on in your institution and what is available. So now we pass to Katerina Panailidou to present the situation in Czech Republic. Katerina?
Yes, let me share. Can you see in full screen?
Yes, perfect.
Great. Okay, so hello from my side as well. I'm going to give you a short overview of the agricultural waste management in the Czech Republic. I'll start with a short description of the sector in the country. The Czech Republic is a heavily agricultural country with 3.5 million hectares of agricultural land, most of which is arable. And as you know, the Czech Republic is a landlocked country, so the climate and the topography of the regions play a huge role in the agricultural and forestry sectors. With, for example, the area of the Czech Highlands, where the mostly moist and cool climate are perfect for dairy farming, for fodder crops and forestry, whereas in South Moravia, the slightly warmer and drier climate is better for agriculture, for viticulture, and high-value crops. And with regards to the animal production, the most prevalent species is poultry by far, and then it is followed by pigs and cattle. In terms of the biomass that is available from our forest and agriculture network in the Czech Republic, we know that the most abundant waste resources are those of plant waste, the waste from livestock production, grape seeds, tillage from distilleries, and pits. And those resources are either directly used in industries that have the capacity to process them, or they are turned into secondary products like biogas or biofuel, compost or garden substrates, mud chips, digestate, and heating pellets. And the industries that have that processing equipment are biomass heating plants, biogas stations, composting plants, dairies, or distilleries and wineries. So in terms of biomass valorization, the Czech Republic is advancing across different sectors. In the agricultural biomass, the primary use is as feed or biofuel with limited utilization in combustion and industrial applications. The livestock biomass, regarding the livestock biomass, the yearly meat production is relatively steady in most species, and recently the utilization of livestock byproducts that are a natural consequence, like manure, has been gaining popularity in farming practices. In the forestry biomass, stem wood and forestry residues are underutilized due to processing limitations, while efforts are being made to focus on enhancing efficiency and diversifying applications, like with pellet production and bioplastics. And with the agro-industrial biomass, the byproducts that are generated by food processing are increasingly integrated in the bio-based industries processes. However, the biggest problem that has been identified is regarding management and logistics. There is a great need for improved infrastructure and cohesive policy frameworks with regards to mainly transport and storage. There is a need for clear borders of responsibility between the actors and a cohesive approach in management and expectations of each actor. So there's a very big need to explore how to better interconnect the different industries and plants to have a more effective waste management and biomass valorization. And there's also a very interesting Zera survey where they noted the insufficient technological interconnection between different plants, the composting plants, the biogas plants, and the wastewater management treatment plants. So to be able to use and explore those connections, there's always a need for further research and innovation. And in terms of operational groups, in the Czech Republic, not many people attempt to form and join in operational groups, even though they prove to be beneficial in other EU countries, mainly because of the financial risk and the financial structure regarding those groups. There are 11 operational groups formed, and 8 of them might have been useful for our BBioNets interests, but now they're all closed. They are from previous years. However, there's a very robust network of research infrastructures and small and medium enterprises that foster innovation in biomass valorization in the Czech Republic. There's a very large amount of projects and quite a few funding opportunities, even national. The projects are mostly focused on the utilization of crop residues and perennial plants, and research on designer crops specifically for optimal biomass content. However, those research results are very useful for farmers, for foresters, processors, and retailers by themselves, but with minimal opportunities for a multi-actor benefit throughout the value chain. So I hope I gave you an overview of the status quo in the Czech Republic, and thank you very much.
Thank you, Katerina. Indeed, it was a nice and let's say useful presentation in terms of what is there and what is still missing. So before we move to the experts' presentations, is there any question for Poland or Czech Republic? Any clarification someone wants to get? So just switch on your mic and camera, introduce yourself and ask. Okay, I suppose everything is clear, or you save your questions for the next part. So now we will enter the presentation of the experts, the panel discussion, where a group of 5 experts at the end. Unfortunately, the last expert could not make it today. It was not possible. But we have the opportunity to be informed about the research work that has been going on, so the knowledge that exists and the opportunities that arise, and on how to valorize, how to exploit the waste. agricultural waste. So the first expert is Piotr Skowron. Sorry if I got it wrong, but from the Institute of Soil Science and Plant Cultivation. Piotr, can you share the screen?
Yes, Jakobos, I can share my screen. Okay. Do you see full screen of my presentation?
Yes, we do.
Perfect. As you said earlier, my name is Piotr. I'm from Institute of Soil Science and Plant Cultivation, from Department of Fertilization and Nutrient Management. I would like to show you some information about nutrient recycling practices, recycling nutrient fertilizers, and take you to the small excursion on our two projects, especially our field and greenhouse experiments. Let's start from definitions. We recognize nutrient recycling like a process where biomass is utilized and or managed to finally end back in the cycle of the use for plants. And nutrient recycling practice is a group of activities, but I've finally effect is the same. We would like to return nutrients for the soil, for the plants, and reduce amount of waste, reduce of amount of crop residues, and make some new kind of fertilizers. On the figure, you see nutrient recycling practices, stages, options, and technologies, and you see that this is very complex issue sometimes, and amount of nutrient recycling practices is very big. We know, of course, that nutrient recycling practices are sustainable, and nutrient recycling, nutrient recovery is in line with circular economy. And let's move to the recycled nutrient fertilizer definition. We are here now. You can find in modern projects in European Union and in your countries, you can find some definitions which are very, very similar, but name of fertilizers are a bit different. Bio-based fertilizers is a definition from Horizon 2020 projects, for example, Lex4Bio, and this definition is in European Sustainable Phosphorus Platform proposal for the new recycled nutrient fertilizers. And recycled nutrient fertilizers definition is from Interreg projects, for example, from Synergy projects. And you can find third definition, alternative fertilizers, is from your Horizon CL6 Zero Pollution projects. And in this definition, you can find very, very similar shape of this kind of fertilizers, and in very, very different names, you can find the same. We would like to change biomass or some different materials, waste materials from sewage sludge and or industrial byproducts to the fertilizers. And next one slide presents you the most important thing from our Synergy project. circular nutrients for a sustainable Baltic Sea region. This project is in progress. We approach to the many issues connected with nutrient recycling, and one of issue is increase for the acceptance and use of recycled nutrients, which is very important to promote this kind of circular economy. We would like to show effects of field scale application of recycled nutrient fertilizers in real condition, and we started 4 field trials, field experiments in 4 locations in Estonia, Sweden, Poland, and Germany, and we totally tested 10 recycled nutrient fertilizers. At the beginning of our work, we were in the preparation phase. We prepared general recommendation and detailed methodology for every location, for every field experiment. And we would like to show for farmers, for scientists, for advisors, that recycled nutrient fertilizers are not worse than regular industry mineral fertilizers, and we can replace part of nutrients in plant production by recycled nutrient fertilizers. In our experiment in Jung experimental station in Grabów, we would like to evaluate the agronomic efficiency of so-called mineral recycled nutrient fertilizers, of course, in comparison to mineral fertilization. And we would like to check impact of recycled nutrient fertilizer called organic on soil macrobiological activities, content of soil and activity of soil organic matter, and evaluate agronomic efficiency of this kind of fertilizer. We are using 3 fertilizers: ASL, struvite, and plant-based digestate. Okay, and on the next slide, you can see stages of our experiment. On these fields, you can see field trials with spring wheat. On the next slide, you can see field trials with maize. Additionally, about this field trials, we discussed with farmers, we discussed with scientists, we discussed with students on the workshop, on the field walk, on the scientific conference, so we could show our work and our results. On the next slide, you can see very first results from experiment with mineral recycled nutrient fertilizer with ASL and struvite, and we find that yield in spring wheat is very similar using recycled nutrient fertilizers and regular mineral fertilizers. And we can replace part of nutrients by these fertilizers. Second project, which I would like to say some details, is org safety. We finished this project this year. Name of this project is Introduction of an Innovative, Cheap, and Environmentally Friendly Method of Hygienization Organic Waste. We mean organic waste like sewage sludge and and digestate, and we find that some plants has biocidal effect on bacteria, parasites, and their eggs, and we called to them like phytosanitizing plants. And we invited method for phytosanitizing, sowing selected plant species on substrates. And first step for developing this method was selection of structural additives for sewage sludge and digestate. We had a mixing test, as you see on these pictures and films. We added structure components. We tested and finding the best, and we found that the best component to the sewage sludge is straw, and the best component to the for digestate is peat. And next step was plant and substrate testing in greenhouse. We tested 8 test plants, and we would like to find four plants for field experiment. After this tested, we find the best plants for our field experiments will be buckwheat, white mustard, oil radish, and marigold. On this slide, you can see these plants. And after this phase, we started field experiment. We prepared special installation for this process. We took into consideration 1 or 2 year incubation of our waste. We need, of course, heavy equipment for preparation. On the next slide, you see stages of field experiment, phytosanitization process, and after destroying plants at the end of first year of experiment, you can see here, we finally had recycled nutrient fertilizer, and in third step of this experiment, we tested value of this fertilizer, nutrient value of this fertilizers in greenhouse.
Piotr,
yes.
Can you please? Okay.
Yes, I am at the end of my presentation. Yeah. Thank you very much. I think I am more or less on the time.
Yes. Thank you very much, and sorry you were faster than me. By the time I was about to tell you to speed up, you thank us.
Okay.
Thank you very much. Now I would like to ask Ms. Anna Klodis from Agricultural Advisory.
Yes.
Sorry.
It's
from
okay.
Agricultural Advisory Center in. That's difficult. Can you please?
Yes, I know. Can you see my screen?
Yes.
Okay, great. Hello, everyone. My name is Anna Goldis, and I represent Agricultural Advisory Center in Poland. And I would like to say a few words about the project that we are a partner in, which is Soil Exchange Project. We have started almost a year ago, and our main aim is to select and present the results of soil-related operational groups. It turned out that despite the fact that we have many operational groups, there aren't so many focused on soil issues. It was very challenging to select them, but we succeeded, I think. These are main objectives. There is a great emphasis on cooperation with AKI's coordination body, of course. We have also analyzed the previous calls for operational groups, and we wanted to improve the next calls for operational groups. However, the crucial outcome will be
sorry, the presentation is not in the presenter mode. It's not changing the slides.
Oh, sorry. Okay, so I will start again. Just a second. Is it changed now or not?
Full screen, if you can.
Yes, I'm in a full screen right now. Can you see the slides changed?
No.
Okay, so sorry, I will try again. And what about now?
Perfect. Thank you.
Yes.
Sorry for that. I didn't know. The crucial outcome will be an interactive dashboard, which will collect more than 60 practices from all these projects. Additionally, 18 of them will be described in details in adaptation guideline. And the dashboard will provide tools to visualize and present data, of course, in an interactive way, easy to understand for non-technical users. There will be short text, charts, graphs using different visualizations techniques. There are expected outcomes in numbers. And just to clarify, what were the conditions that were required for the selections? They were not very demanding. One thing that there have to be one or more sustainable soil management practices. And second one, the quantitative result to show us, to prove that the project improved somehow soil quality or soil health. These are examples of our national node. We are, of course, hoping to grow it, but now we have 8 operational groups in these national nodes connected with soil exchange. First one, Stobrava, they are very into biodiversity. They use agroforestry, the interrow, alternating cultivation of trees. The goals are activate the soil in the planting strips, and of course to preserve the environment and to increase biodiversity. Soil was enriched with biologically active organic matter used also as a cover mulch. The substrates were activated with biologically effective microorganisms and trichoderma fungi. And in order to increase the quality of yields and for the climate change risk mitigation, biostimulants based on silicon and chitosan were applied during the growing season. The project outcomes were quite promising, very positive impact on soil moisture, and what is really important, a positive impact on populations of beneficial species, earthworms, pollinators. I don't have time for every slide, sorry for that. Innowacyjna rzodkiew, so innovative oil radish. They focused on cultivation of a new variety of oil radish with favorable effects on soil structure, compactness retention, and also on agri-technical improvements in intercropping cultivation with fertilizing effect of mulching. And the goal was obviously to create a new genotype of oilseed radish, but also to improve the technology of growing oilseed radish and to increase the contact of nutrients and organic matter. Project outcomes also very nice, very positive impact on reduced surface runoff, nutrient recycling, soil organic matter. Once there is zero tillage, they were obviously focused on zero tillage technology with live mulch for winter rape and wheat. Direct sowing of winter wheat and winter rape with seeds selected for live mulch. Goals are very general, I won't be focusing on that. Direct sowing of winter wheat and winter rape with seeds selected for live mulch was done. Also, living mulch was left as a plant cover, consisting of trefoil, limb, and maintained for the duration of the project. Outcomes, very positive impact on soil moisture and cover, reduced soil compaction, and nutrient recycling. Basidrill, another operational group, they were working on innovative seeder for grassland over drilling, and the seeder was upgraded with a coulter with an innovative system for introducing seeds into the soil, a device for combing out dead plants parts and other elements such as fertilizer box, a container for plant protection products, and a GPS system. And the goals was to, of course, improve organic matter in the soil, to improve grassland production, to reduce land degradation, and to improve groundwater management. Nitrogen loss was reduced through a better use of fertilizer ingredients, a very positive impact on reduced surface runoff and soil cover and soil organic matter. The proposed oversowing technology can be used in a various farming system, both in conventional and organic farming. The proposed technical solutions are universal, can be used not only on grasslands, but also on arable land. And the impact of the project hopefully may be nationwide and European, especially in countries with similar climatic conditions. Woda dla Kujaw, water for Kujawy. Kujawy is the region in Poland. They focus on subsoiling. Subsoiler is pulled by a tractor and breaks up a compacted layer below the surface. It loosens the soil but doesn't invert the soil. The goals are to enhance water harvesting, to improve production, restore soil properties. The subsoiling used instead of typical ploughing helps to reduce surface erosion. As a loosening treatment, it exposes the soil to water and wind erosion much less than ploughing. And what is really interesting, the beneficial effects of subsoiling for better yields are visible, especially for root crops. And the yield forming effect of the treatment is visible throughout the crop rotation. And project outcomes, very positive impact on reduced soil crusting and reduced soil compaction. Roztocze cannabis. Roztocze is also a region in Poland. The project has developed a strip till unit with variable seed and fertilizer application rates, allowing seeding at different row spacings and using field mapping GPS systems. And it gains value by positively impacting the soil in a low invasive way, increasing organic matter content, eliminating plowing, protecting it from water erosion, wind erosion, and nutrient loss. Another project, SFC-FTF, fertilization optimization. They wanted to achieve accuracy in predicting the demand for nutrients by crops using artificial intelligence. Of course, the obtained results will allow for optimizing fertilizer doses also in terms of protecting the microbiological biodiversity of the soil, which is, of course, one of the factors that determine soil fertility. Using the system on a farm will allow for obtaining optimal yields in given conditions, reducing fuel consumption and mechanical wear of machines, and limiting the negative impact of microbiota soil, especially on the beneficial microorganisms for plant. And the last one group from our national node is Maszyny. This is ongoing project, so this is a very general description. The main goal is to develop an innovative agricultural technology, including a machine with a modular design for multi-purpose use in different types of crops. And the technology aims to improve agricultural productivity, optimize resource consumption, and minimize environmental impact. There are numerous benefits to using this technology, including improved soil quality, reduced erosion, better water management, and reduced nutrient losses. Thank you very much for your attention. And I would like to say that we are now in the process of collecting this detailed data. So if you are, I would be more than happy to answer all your questions, but I would probably not be able to answer them now because we are in the process of gaining the information. So if you have any question, just write an email to me and I will come back to you with all the information after discussing them with operational groups. Thank you.
Thank you very much, Anna. And sorry about your name. I misspelled it in my notes anyway.
It's absolutely okay.
And just a note for everyone, the soil exchange project is the sister project of BBioNets. They were both funded under the same topic. They started the same, I think the same month, or anyway, with 1 or 2 months difference, and they have similar goals. Of course, each one has its own activities and planning and target regions, but we are going together. So
that's right.
Now, please, Magda, from our colleague from the Institute of Soil Science and Plant Cultivation, talk about digital tools. Magda? Please unmute yourself.
Okay.
Now we can hear you.
Now you will see my screen in a second. And now you will see my presentation in full mode.
Yes.
Yes, perfect. Good morning, still everybody. My name is Magdalena Bożeńska. I'm representing Institute of Soil Science and Plant Cultivation. And I will tell you a little bit about the digital tools to support nutrient recycling practices. What types of tools we will talk about, and what I'm working with. It's a kind of inventories of best practices, e-learning platforms, self-assessment application, B2B matchmaking tools, and biomass availability tools, which in Institute we especially work with. A lot of work with those tools was done within Mainstream Bio project, where I work with 10 partners from 9 EU countries. We contact and we talk with farmers, bio-based industries, innovation, researchers, and technology providers. We collect a lot of data about the different kind of information, and we have put all together in this nice looking digital toolkit. This digital toolkit collects and presents small bio-based solutions and technologies, business models, and social innovations in a kind of catalog. We have the bioforum, a decision support system for matching biomass and waste streams, a collection of best practices, bioeconomy repository, or a nice, quite big tool library where we have collected tools from different projects, and they are available at one address to be looked at. The decision support tool can be used especially for young students, innovators, people who has a lot of feedstock, but they don't know what to do with it. So you can use our decision support system to design your model of feedstock technology, and then come out with the product. We talk more and more about social impacts of our innovation. So here in this decision support system, you can also see your impact, also economic impact, and then you come out with the radar chart where you can see the scores of employability, social impact, economic impact, or environment impact. You will have nicely presented to what are your strong points of the project, what are the lower points, and where you should improve. Also, there is a nice catalog of small base solution where there is a lot of information about the different kind of technologies, how they can be implemented, what kind of budget you need to support those initiatives. There is also a catalog of nutrient recycling practices. If you need to improve your knowledge, if you want to learn more, you can search, for example, if you have manure and you would like to know what to do, what kind of technologies you can use for your manure, what can be applicable for your farm or your center. If you like to know more, please visit us at Mainstream Bio Toolkit and learn more about it. There is another project that we work in, and we also work on digital tools, as my colleague Małgorzata earlier said about the geoportal. But geoportal is not all. You can find colleagues who works in similar projects. Here you can kind of see the number in each country of experts, innovators who use this tool to work together and come out with different ideas. If you need to search for information, you can go to bioeconomy inventories and search through the keywords through the bioeconomy themes and learn more about ideas of what are being done in other countries. You can also search through a keyword like nutrient, and then you come out with nutrients to close fertilizer cycle or many others. We also have spent a lot of time on working with specific biorural success stories, and those success stories also talk about innovation and nutrient recycling practices. One of them is Planteo, which is innovative solution for production of organic fertilizer. The company works a lot and is linked to production of energy, so biogas plants, and the leftovers are being used to produce high quality organic fertilizer that can be used by farmers, by gardeners and small entities. It helps to increase the income of the company. And if you would like to know more, please visit the BioRural Toolkit and learn more, become our members. Thank you very much. I hope that I did manage to use my time. And
yes, indeed. Thank you, Magda. And just to add to the tools that you mentioned, that in BBioNets we are there's already.
Yes.
Please say a few things because you developed it.
Yes, we also developed the tool like that, where we are analyzing different countries. Those presentations that were made by Małgorzata and Katarina earlier are being presented also over there, so you can go to see those kind of country updates. There will be also a tool that will help us to choose the best practice to manage our OG groups or our ideas. This tool will be available probably in January, so at the next meeting we will be talking much more about it.
Thank you, Magda. Everything is accessible through our website, so stay tuned. And now, Nikos, your time has come. Nikos Larkos, from Agrotech Innovations. Please.
Thank you, Iakobos, and thank you for all the previous speakers. It's just like that they prepared the grounds for my presentation. Because, you know, the three main keywords that we heard so far is this reuse and recycle, the reuse of nutrients, let's say, the mainstreaming of small-scale solutions, which is key for adaptation and adoption from the rural communities, and helping in the ground, because that's where the issue is. So thank you for all the previous speakers, and I'm going to refer to a specific case which we implemented to support an OG here in Cyprus. The map still doesn't show the OGs for Cyprus because it's still ongoing and we are closing them now. And it was referring to agriculture and forestry waste management within the circular bioeconomy model. So we are based as a company, as an innovation broker within the AKI system. So our mandate was to create this OG and help in the transfer of knowledge, know-how, and the implementation of this new technology, which is part of the bio-based technologies as the project. So what was the real issue? The real issue was, as according to FAO, we have this climate change, we have water shortages, it's all over Europe, rural poverty, agricultural land scarcity, and we have this big impact in the industry. The current situation is really bad. We have many kinds of losses, ecosystem services losses, fresh water, biodiversity losses, land degradation. We have this deforestation issues, of course, the pollution of nutrients, which actually, as mentioned from Piotr, this can be turned around. All of this situation can be turned around. This is the case of the circular bioeconomy model, which the principle is from take, make, and waste to replace, preserve, and avoid. These are the three circular economy principles that we can apply on the agriculture and business forestry sector. So what's replaced? Pollution and waste are replaced to become regenerative, avoiding harm to human health and the environment. Air and soil water pollution is avoided. Fossil fuels and chemicals are being replaced by natural products and renewable energy sources. So the case is to find new resources, because we have resources scarcity. So we can find new resources and new materials, as we have been seeing so far. We can find new sources of nutrients. We can find new sources of helping agriculture move forward without getting them again from the Earth's crust or below the ground. Preserve. We need to maintain the value over time, targeting durability, reuse, remanufacturing, recycling, everything that we saw so far. Maximizing and upgrading of biological material before it returns to the natural ecosystem system. It's what we saw with this upscaling and mainstreaming low-cost solution, as we saw from Magda and the other presenters. Therefore, the principle is to gain value from waste. This is what we have seen so far. To develop byproducts that could serve as an input or open up new market opportunities. Again, this all that we are discussing needs to have a real market impact, so it can be adopted and be incorporated in day-to-day business. Combined with entrepreneurship, we have the potential to create new business and new jobs for young people to get involved in agriculture and forestry. Avoid. We avoid the use of non-renewable resources and returns valuable nutrients to the soil to support natural regeneration, as we have seen. At the same time, it will avoid trade-offs that could damage biodiversity and will promote synergistic measures to protect biodiversity. They are avoiding loss of biodiversity from genes to species and ecosystem, could also help avoid threats to human health in the future. So how do we do this? How does this look like? Looks like a bit like this: utilization of waste from the agriculture and the forestry sector. Everything feeds the next stage, and then the next stage feeds the next stage, and then we have this zero waste and highest utilization of all resources system that can be imagined. It's a difficult thing to implement, but this is why we're here. So from the bio-based technologies that we have been involved with, pyrolysis was one of those, and it's one of our main activities to look, support, and elevate the efficiency and adoption of this low-tech technology for the benefits of the rural areas. So far, it's good that we haven't mentioned it so far, so it's something new for today. And we will see also the role and benefits of biochar, which is produced from this procedure. I'm going to talk about batch slow pyrolysis, which is a thermal decomposition of organic materials at high temperatures in a closed system or in an oxygen-free atmosphere. As you can see, we have all kinds of biomass that you can imagine entering the system and producing this really valuable resource. Has tremendous benefits and serves most of the EU Green Deal and the UN SDGs, and has more than 55 current uses, industrial and non-industrial uses in agriculture and forestry and environmental management and anything you can imagine. Return to the soil, can boost crop yields, reclaim mine sites, sequester carbon. It's a growth media for greenhouse, clean up wastewater in the energy sector. There was a big oil spill in the Gulf of Mexico, and biochar was used to treat this big oil spill and along with other means. Biochar, of course, is one of the outcomes of the pyrolysis procedure. We have also bio-oil, syngas, heat, and steam coming out of this procedure, which can be utilized in many, many directions. It's a stable organic carbonaceous product with a clear and precisely defined quality based on the feedstock that's used to be produced. Let's keep this point and we're going to discuss it further. As I said, has more than 55 potential cross-sectoral uses, and as you can see, its nature and co-products serves most of the UN SDGs by various means and aspects. Can be produced from all kinds of organic material, energy crop, forest residues, agricultural residues, whatever. Other materials can be used also industrial waste, sewage sludge, waste from food processing industries. And each of these raw materials has a different chemical composition and physical properties which affect the quality of the pyrolysis product obtained. So this creates very specific products for very specific uses. This is how it looks from you have two different sources here. This is from an electronic microscope. It actually seems as the plant cells that it comes from, or the structure of the organic matter that it derives. So the case is create this added value. Instead of having waste, having new resources and new materials which affect the local economy, the national economy, regional economy, doesn't stay only in the rural area, it goes beyond the rural area. So as you see, we have this valorization of waste. We can have many chemicals extracted or, of course, of natural origin, other kind of solid material, or again, we can also have some valorization of everything that's contained in this solid liquid waste, as also Piotr showed in his diagram. Thank you. I was short. I hope it was informative and interesting.
Certainly was interesting. That I have my own notes for later on for the discussion session, but I suppose everyone does. Now, our last expert, Clara Fernando Concillas from Danish Technological Institute.
Yes. Just one
Clara, the
second.
floor is yours, the E-floor.
Just let me try to share. Can you hear me well?
We can see you, not your screen.
Yeah, because I'm trying to find.
The arrow on the bottom, there's a number of items, of boxes. There is one
Yeah, I see the
arrow,
present now.
and then box opens. So you can choose either the presentation or the entire screen, or
Could it be because I'm opening from the incognito mode that I cannot see my file in my. Sorry, I never use Google Meet, so I'm not used to this. Just one second.
Mhm. Just to remember all the speakers to please send me the presentation, if you want, that is, to share it with everyone, have it available. Clara, everything set, or
I'm trying to.
maybe the incognito mode prevents you? I don't know.
Yeah, maybe it is, but then I would need to hop out.
It's a classic solution. Get out and get in again.
Yeah. Maybe can you see something now?
Yes. We see your screen.
Full presentation now?
No, we see the folder, the files.
Only the folder.
Yes. Oh, I don't know if you open the presentation, then you should share your presentation, or I mean, just use the entire screen and.
No,
Can you
because
just-
now
Can you open the PPT?
yeah, I'm trying to double click and it opens in my computer, not in the screen you
So
can
you
see.
need to first open it and then share your screen.
Yeah, I have it open already.
Then stop sharing and share your screen again.
It's like it doesn't appear in my Windows to share.
Well,
I'll try to log out and log in again. Sorry.
okay. While waiting for Clara to rejoin, just to remind everyone that the presentations are the results of the work that has been going on through similar projects. So there is a lot of work and knowledge out there to reach out. Clara? Okay. Now it's done. It's okay. We can see it. We cannot hear you, so you need to unmute yourself, but we see your screen.
Perfect. And you can see that I passed the slides as well.
Yes, yes.
Okay. Sorry for the delay, but thank you for the invitation. even though it says in the first slide that it would also be my colleague Annie, she will not participate in the end, so it's going to be only me. And I'm going to be presenting a very specific example of the BBioNets project. I think you have heard about it or presented it before, so I don't have a lot of information about the BBioNets project, but it is a big European project in which we are several countries involved. And we are working in 3 countries with pilot plants in Spain, in Italy, and in Denmark. I'm going to present the Danish case. I work at the Danish Technological Institute, and we are a research center in Denmark, where in my section specifically, we work a lot with agricultural wastes, and now we are focusing a lot on new protein sources and food products. So this is a bit the case in this specific project, in which we have used rapeseed cake for the production of protein powder. So in this picture, you can see an overview of the Danish case. We are 3 partners involved in this specific case. The first one is DLG, which is a Danish cooperative, and they have all the contact with the farmers. So in this specific case, they are taking care of growing the rape seeds, harvesting the seeds, and pressing the seeds for oil. They have oil as their main product, and the side stream, which is the rapeseed cake, is one part of it is delivered to us. Nowadays, well, rapeseed it's quite common in Denmark, so it's one of the main rapeseed oil, for example, is the main one you can see in the supermarkets. But that also means that there is a lot of rapeseed cake as leftovers, and one part of it is used as feed for animals. But this needs to be controlled because it contains something called the anti-nutritional factors, so it can be potentially toxic for animals. So it has to be measured how much, or it's used in a small percentage for feeding the animals. So the idea of our part in the project is to use this rapeseed cake to extract the protein. So in the Danish Technological Institute, we are working on developing a process in which we can extract this protein and obtain a final product, which is a protein powder or a powder rich in protein. And then this powder is used for 2 different purposes. One of the purposes is the food industry. So it could be used as a protein source for, it could be baking products, it could be milkshakes, it could be whatever product in which a protein powder could be added. And we all can see now in the supermarkets and everywhere, there's a high trend now in eating products that are high in protein content. So it fits pretty well. The other option for our powder would be for the production of bioadhesives. So in this case, it's our partner called Himar from Greece, and they are focused on the research for producing bioadhesives that are more environmentally friendly. So they are working on the substitution of phenol for some resins, and then these resins are used for the production of plywood. This is in general terms for our case. I can show you in detail what we are doing here at the Danish Technological Institute. And here I'm just sharing some pictures so you can see how we work with it. I personally like to work with pictures, not so much with text. So I just wanted to present here on the left side, we have a picture of how the raw material looks like. This would be a rapeseed cake that has been cold pressed. And this means that the rape seeds have been pressed without the addition of any heat. So this is what the cake looks like. So in our pilot plant, we always work with wet processing. And that means that we mix the raw material with water, and everything is pumped through our equipments. So here on the right side, you can see a picture of our 2 tanks, for example, where we have been starting this process. So in the picture in the middle, you can see how we were adding the rapeseed cake to the tank, and then that's mixed with the water. Here on the left side, there is a blurry picture because it was in movement, but that's the inner part of the tank. So you can see how the mixture of the rapeseed cake with the water looks like. And then just some more illustrative pictures. So you can see in the middle our tank and how it is connected to a decanter, so we can separate solids and liquids. I cannot give you a lot of details of the process, but as I mentioned, it is a wet process, so it's all liquid. So we are removing all the solids and we end up with a liquid that is rich in protein, or the protein content is high. And this liquid is then dried, so the powder looks like the picture on the right side. It's a very light color powder. We have done some tests to see how we can use this powder with the two applications that I mentioned before. Here on the left side, you can see two protein powders, and it says HPR and CPR. That HPR stands for hot pressed rapeseed cake, and the below one for cold pressed rapeseed cake. And that's the only difference is the temperature when the rapeseeds were pressed. So we have tried with both types of powders, these two applications. The first one in the middle is the adhesives. So those are some pictures from our partners in Greece, and they have shown how the color of the resins and how it looks like when they are using part of this powder to substitute the phenol. On the right side, where it says food products, we can see a picture of some muffins. So we did a test using this protein powder and substitute some parts of flour in the regular muffins. We did a lot of versions with different percentage of substitution of the flour, with chocolate, without chocolate, etc. And we did an internal tasting, so people could actually rate the muffins and see how much percentage of this protein powder was affecting the taste, how it looked like, etc. As very quick results, just to mention that the protein powder that we have obtained until now, we have managed to reach up to 45 to 50% protein content, and this is based on the dry matter content. And in the baking tests, most of the people could feel there was some aftertaste because it has some bitter taste. But we managed to cover this a bit with adding some chocolate. So most of the people would actually prefer the chocolate version of the muffins. We had the same muffins with and without chocolate. I want to mention here that I mentioned at the beginning that this material contains something called the anti-nutritional factors, and that's also something we are researching now because the project is still, we still have 2-3 years to go, but we're also identifying or measuring how much of these anti-nutritional factors we have at the beginning and at the end of the process, because we're also trying to remove these components during our process. So it could, so we make sure that there's no potentially toxic compounds for human consumption. And as main highlights from the production of bioadhesives using these powders is that our partner, they managed to substitute phenol up to 20 and 40% as substitution levels, and they didn't find any issue with the different tests that they do. So these tests with 20 and 40% substitution managed to meet all the standard requirements. So now they are aiming to substitute even higher percentages of phenol substitution. But as I mentioned, we are still ongoing in the project. So we are optimizing the project, the process in our labs, in our pilot plants, and hoping to get an optimal process for an optimal product. And that's it from my side.
Thank you, Clara. Before we proceed to the questions, Clara, everyone survived the tasting, huh?
Sorry?
Everyone survived the tasting.
Everybody survived, yes.
That's
we also
great.
have, we also do tests to make sure that their microbiology levels and so on, everything is safe to eat.
But
so it was just a bit, I also tasted, and it was just a bit, it was weird because it smelled like something salty, like bacon could be, but then it was a muffin with chocolate. So it was very interesting, but everybody survived, yes.
You started with the bad colleagues, and then you continue eating.
Yeah, we made a test, yeah.
Perfect. Well, thank you very much for this. And now we will enter the discussion phase of this meeting, where we prepared a couple of questions for the experts. But obviously, if anyone of the audience has a question, just raise your hand, or speak up and address it. Present yourself and then address it to the correct person. Magda, can you take now the lead?
Yes, thank you. Do we have any questions? Is anybody wondering a part of the taste of the muffins?
I don't see anything in
I
the
bet
chat.
I would eat them because I like the salty cakes, so something for me. But anyway, if
we need to taste them, Magda. You need to send us a Christmas gift.
Well, yes, we will try to communicate with Clara and see what we can do. I'm not promised cake baking myself, but let's try.
Make a Christmas batch and send it.
We will see how we can do that. So if we do not have any questions from audience, I would be interested in talking to Anna. If Anna could tell me something more about those operational groups that are working in Poland, because one of them you said that it's just at the beginning, the last one from the green, but the others, they...
Not at the beginning, ongoing. They are going to end in a few months.
Are they ready to be like operational soon? Are they going to be commercialized?
Actually, these groups which are involved in creating some new machinery or new technology, they for sure think about commercialization. But we have in Poland, we have more than 230 operational groups with this innovative component, and the rule is that the operational groups working for the wider audience, and sometimes the plans for commercialization stop them from being transparent for advisors. This was problematic at the beginning of the project, because we needed to select groups which are willing to share their results. And sometimes we approach them and the answer was no, because we are going to commercialize it and we don't want to share it in details. There are some groups which are only in the project for some idealistic purposes. For example, Sobrava, they're into bees, apiary and biodiversity, and they are very open for sharing their results, but some of the groups are not that into sharing, and it's sometimes really problematic. And I've talked to one of the person who is responsible for operational groups on the European level, and they said, that's great to have so many operational groups in Poland, but the problem begins when farmers don't have any clue what we're doing throughout the project. So this is the problem that needs to be solved. Operational groups need to know that they are, they are spending like public money for the wider purpose, and there's some idea behind it, not only commercialization itself.
Yeah, we're facing quite similar problems in our project. So I hope together we can work with farmers and convince them to tell us more about the success story. Thank you very much, Anna, for your time and sharing of the knowledge. I was listening also to Piotr Skowron, and I have one question to him about the new fertilizers in Poland. What is the status of it right now? What are the perspectives for development? And to be honest, if farmers can use them, if farmers can easily, I don't know, make a production line, if they have too much manure, can they do something with it?
Mm-hmm. Okay, when we took into consideration overall group recycled in fertilizers, some fertilizers are a very simple process of production. It is possible to do it in the farm, but if we talked about more complicated technology, like for example when we talked about renewal of a group of fertilizers, because renewal fertilizers are new group which will be explained and put into the law in the annex to nitrate directive, I think probably in next year. When we talked about renewal, we have to know that process of production of renewals is very complicated, and it is possible rather in enterprises, small enterprises, maybe locally settled enterprises, but parameters are very specified. High amount of mineral nitrogen, special rate to the organic carbon. And I showed two renewable fertilizers in my presentation, because in Synergy project we have experiment with struvite and ASL, ammonia sulfate liquid. This is the two renewable fertilizers, and of course recycled nutrient fertilizers in whole group. And of course, in production of these two fertilizers are engaged rather enterprises, not small, I would say. But of course, potential is, especially in countries with small countries with very high level of animal production. In Poland, we have situation that we in we have area with high concentration of animal production, but we need add big amount of organic matter to the soil in fertilization process. So decision is very hard. Very easy is in small countries like Netherlands, for example. They have very small amount of very small area for using manures, and they would like to sell nutrients outside abroad. And decision is very simple in this country. In Poland, decision is not very simple.
Okay, so as you say, probably for us it will be much more profitable to use directly organic fertilizers to the ground, as we have those kind of soils that requires a lot of organic matter.
It depends, Magda, because everything depends about cost, local availability of manures, and availability of technology or enterprise who could prepare processed manure. It's a very complicated, but if business environment will be good for these activities, I think that we have chance to do it this way.
Okay, so it would be really profitable for the farms, which we were talking about earlier, like landless farms, which they have only, I don't know, for example, pigs production, yeah, and they don't have land to spread the manure over it, and they could use those technologies to kind of use the waste to convert it to profitable nutrient.
Yeah, our experiment in org safety project, we started in the area of company who has very big production, and they finally, after processing, they have big amount of digestate, and this digestate was contaminated, and they couldn't use it on the fields, but after processing, they could. So in that case, was a good connection between animal production and plant production, and one company who has also animal production and plant production, and possibility and enough power for investments to do it this way.
Okay, thank you very much. Your explanation have raised Nico's hand, please.
Yeah, I just want to add to what Piotr is saying, because finally we came to the point where we need to do all this in a business model innovation scheme. So 10 years ago, I was more than 10 years. Let's say I was working in the agri supplies sector. So fertilizers, pesticides, everything. So I came across a Portuguese French company, fertilizer company, chemical fertilizers, which they owned 2 million ships. I mean ships, I mean not the ships in the sea, I mean goats and sheep, let's say. They were owning 2 million ships, and they were taking the manure from those ships and liquid and solid waste. They were doing all this, what the Piotr was describing, to have a portion of nitrogen, let's say, or other kind of nutrients being incorporated in their chemical fertilizers. So this is nothing new, let's say. These are new kind of resources that can make the farmers or the rural communities, being from consumers only to this new term we are saying, prosumers. So they can also be the producers of new materials or new raw materials for the industry, all kinds of industries. We saw before also with Anna, we also saw with Clara something. And this creates a new ecosystem where these things can develop. So the question is, what is feasible and what is financially stable and efficient to happen? The possibilities are there. It's just the how. It's not the if anymore. Can be done, but you need to put these financials in front.
Yes, listening to you all, it gave us proof that all things can be done. Now I will pass the floor to Valentina.
Yes, thank you, Magda. Nikos, having said that, can you please analyze what are the crucial steps in achieving maximum results from forestry and agricultural waste management? Please.
Yeah, well, yeah, of course. So I'm going to use some industrial terms, because we have been saying so far about this new model where we're going to do this reuse and recycle and everything, but it all comes down to the quality parameters of the material that's going to be used to be processed. Okay, so very crucial stage is the characterization of this material you have to put it in this procedure. I mean, you can have the same forest waste, let's say, coming from pine trees or coming from, but the same in different regions, and the quality parameters, it will be totally different, because these are biomaterials actually, and their quality and anything that happens afterwards in their process is based on the environment they grow on, the ecosystem they exist. So this is why we have seen also in the pyrolysis procedure, where we had 5 different areas which all have olive trees, because in the Mediterranean we have a lot of olive trees, and it's a big waste, also vines for making wine and everything. So we had them in 5 different areas, and when we pyrolyzed them and then we analyzed the properties of biochar being produced just from olive, we had like 5 different things. by different biomes. And when we applied them in agriculture, we applied them as soil amendments, we applied them in animal farms to reduce the odors coming from their waste, from their manure, or to use them in the beds of the animals. Try different things. We saw that they were affecting these attributes. They were different. So very, very important thing is to know what exactly is your raw material that you are going, before you even put it in the digestate, before you put it in the composting procedure, before you put it under any other process you want to get out something from. That's a very crucial step. Again, you need to monitor the procedure, the conditions of the procedure. Again, the conditions of any procedure of what's it called now? It's called bioenhancing or biotransforming or whatever. They are crucial. You need to monitor the conditions of this procedure very precisely, because it plays a big role on what you're going to get at the end. And after you do that, you need to target specifically the use of these materials. Either it's going to be used for water management or for environmental resources or for soil, or you're going to use them as carriers of nutrients. Maybe let's say you can find a solid granular produce of these processes, and it can be used with the nutrients produced by this cycling that Piotr has described, and can be used as their carriers into the specific use we want to do them. So these are the three, I think, more crucial points in this procedure.
Great, thank you very much. And you mentioned in your presentation about the EU Green Deal and the UNSD goals. Can you please tell us how do the bio-waste management derivatives support the EU Green Deal and this United Nations Sustainable Development Goals?
Yeah, well, I think it's a cornerstone for actually being able to do something about these goals. Because if you want to reduce hunger, reduce poverty, have the natural resources available for everybody and in the quality and quantity that needs to feed the world, or to, all of these things, I think it's my belief that using bio-based technologies to transform bio-based materials which were going to go to waste, in the purpose of actually increasing the ability of the planet to produce food in an efficient way, and not wasting or using more resources that it's needed. So we don't have any surplus. We are also some surplus. So we don't have surplus. So if we want to find our way towards those goals and to this the targets set by EU Green Deal, the key is to stop overusing. Overusing was what brought us here today. Overuse of natural resources, overuse of human resources, overuse of something. So when we stop overusing and use all this surplus that we create or created so far, and just have an equilibrium of a balance of what we need and how we produce it, I think it's the cornerstone of everything. And bio-based technologies and these methodologies and activities we have been discussing is a key component.
Thank you very much. I don't know if anybody has any question for Nikos. Otherwise, I would like, I'll wait. Otherwise, I would like to ask Clara. I don't know if Clara can
Hi.
hear me.
Yes, I'm here.
Okay, thank you, great. Clara, which sector or industries could collaborate efficiently in a circular bio-waste management value chain?
I think based on my experience here, basically any sector. I think here there's something also about the wording, because I think we tend also to talk a lot about waste streams, and we'd like to talk more about side streams maybe, because waste already has sometimes a connotation that it's not useful or suitable for any repurpose. So yeah, I'd like to talk about side streams instead. But I would say, again, based on our experience here at the Institute, I think that potentially any side stream could be used, because we focused a lot on working, trying to extract any, could be carbohydrates, could be proteins, could be fats. So any side stream that can contain any component that could be revalorized would be suitable. You have also been mentioning that we are getting better at proving that things can be done. Then, of course, another thing is the environmental and the economic assessment. But technically speaking, they are feasible. The extraction of these components of almost, I would say, anything. I'm thinking of what we work here, and we have worked with agricultural side streams, but we have worked with insects, we have worked with plant leaves, we have worked with any stream that companies could not do anything with, and we have been focusing on the extraction of these proteins, mainly for the food industry, but there's a huge variety of companies or sectors.
Thank you. I had a problem to unmute myself. Yes, thank you. And could you please share with us what are the common challenges hindering process in waste management?
It is not my expertise field. I'm working more with the technical part in our pilot plant. I cannot tell you on a Danish level the main challenges. I can imagine that maybe they are not as different as in the rest of Europe. I know, for example, that from if I think more about the Brilliant project, in which we also have cases from Spain and from Italy, and we have been in contact with all the farmers trying to identify. We did a SWOT analysis trying to identify the strengths, weaknesses, opportunities, and threats. I know many of them mentioned, just as an example, how climate change is impacting them, but I think many times it's also about the policies, the European policies, which I have to say, I have to admit, I have not a lot of knowledge about, so I cannot tell you much about it. But as I know, in the Danish case, the business model that they have with this cooperative, I think the farmers, they seem pretty satisfied. It's working pretty well. So I cannot tell you if there's a specific issue with transportation or with the logistics, because Denmark is also a very small country compared to many others in Europe. So I can assume that things are also maybe easier. And I guess it also depends on the crop that they are working with. So I don't have a specific answer because it is not something I'm working on an everyday, unfortunately.
So the smaller the country is, the difficulties are less, let's say.
I assume so.
Thank you very much, Clara.
Thank you.
Well, thank you, Valentina, and thank you, everyone. If I may summarize, I mean, it was quite surprising something, and if you please, Anna, to elaborate a bit more, what you said about to the extent that the farmer, we are piloting and developing many things on the field in collaboration with farmers, but you said that, if I got it correctly, many times they are not aware of the technology and the possibilities, I mean, of the OG, what is going on their field. So that knowledge, even at technical level or business level, is not reaching the farmers themselves. Is that correct? Did I got it right? You are muted. Sorry, you are muted.
Sorry. It's when I started to search for operational groups for this project, and I started to talk with operational groups about, sharing the results. I started also to search for and asked farmers what they know about previous operational groups' results. And it was really depressing. They have no idea what was made by previous operational groups. This is something we need to cope with, we need to discuss, we need to approach systematically, because there's a lot of knowledge which is undelivered, I would say, to the farmers, and it has no point to realizing these projects without these final steps to be accepted by farmers. That's why soil exchange is that important, and I believe in this project. And we will be on February, we will start another sister project connected with water management in farms, also from the results from operational groups. And we need to underline before the call is started that these projects need to be delivered for the farmers, because I'm not sure if current operational groups are aware that they should share their results.
Being aware of the obligation is one thing. Actually, sharing is another. So,
yes, they have this obligation to actualize this website, but when I've searched this website, they have no information in them. There's so general information, and it gave us absolutely no clue about the project. So these groups are great groups. They are really willing to cooperate and share their results, but I must admit it was really hard to find these groups.
So bottom line is that there is a lot of research going on. I mean, what Nico said, what Piotr said, what Clara said, but it's not that easy. And if they reach the starting point, the farmer, I mean, we can talk about business plans. Nico?
Iago was sorry, but just to give another push to what Anna is saying, there are more than 3,600 OGs in the EU, more than 3, and the goal of the EU is to make them like 7,000. I don't remember when it's the new one. The OGs has something hidden. The real scientist of the OG is the farmer, and this is overlooked in all of them. Well, I have been to EU CAP network workshops and webinars, and I was part of many of their activities, and not even once the significance of the farmer for the OG was mentioned. And when you start something and you have your who is my key stakeholder, who is a key person. We mentioned key personnel on this and key personnel on that, but we should put the farmers on top, that they are the key personnel. And that's why they don't get this information, they don't get this know-how, they don't get this knowledge that they help to produce. Without them, no knowledge can be produced, or know-how can be transferred, or technology be used. They are the key of everything. But this role is being overlooked, and it must change.
Now more and more they start this trend. I mean, without the farmer, there will be no food. So that's the campaign nowadays. Of course, it's not only the food, but also the side streams.
It's not true. Again, we find these marketable things that we say that we need to increase awareness. No, if you take away human from the production, nature will produce again as it was producing in the past. The thing is that we need to increase the capacity of all the stakeholders to do what they already do, but better. It's not a question of who is best on this. Without Anna and without Clara doing their work again, we will not have something. Without Piotr the same, without Magda the same, without Iacovos the same, we will lose a link on the chain. This is a chain that needs to be stronger, not to say who is more important and then okay, he's less important, let's take them out of this chain. No.
Okay, well, thank you for this very useful discussion. We could go on for hours, but time is passing by, and I think it's time for the group photo. So, if wear your smile and switch on your camera, and Daphne will take a smile also. Daphne, just tell us when it's okay.
Okay, give me a second. Sorry. Smile. Thank you.
Okay. Perfect. Ladies and gentlemen, thank you very much for your attention and commitment to this 2-hour, it's 2-hour only, discussion. We will be in touch with you for the next steps in terms of, I mean, this session is recorded and will be uploaded. The presentations will be shared, and more activities like these discussions and presentations will arrive in the future. So stay tuned and have a nice noon, I suppose, in your place. Okay.
Thank you.
Bye-bye.
Bye. Thank you very much. Bye.
Thank you very much.
Bye.